Hello everyone, in this video we're going to review AB, calculus AB and BC. Topic error, accumulation and approximation. Alright, before we're going to dive into the questions, let's review the concept behind this topic. Alright, we're going to talk about the left and right Riemann sum. Alright, so here's the way to justify for over and under approximation to earn full credit on the AB exam. Now, if the function fs is increasing, in other words, f prime of s greater than 0, the left Riemann sum under approximates the error because fs is increasing. The right Riemann sum over approximates the error because fs is increasing. Now, if the function fs is decreasing, in other words, f prime of s less than 0, the left Riemann sum over approximates the error because fs is decreasing. The right Riemann sum under approximates the error because fs is decreasing. Alright, now this one is the mistake you need to get rid of. You cannot say the left Riemann sum is under approximation because the rectangles are underneath or below the graph. Saying that the rectangles are below the function is not acceptable mathematical reasoning. It merely restates that it is an under approximation but does not explain why. Now, when it comes to trapezoidal approximations, we need to explain like this. The function fs is concave up or f the prime of s greater than 0. The trapezoidal sum over approximates the error because f the prime of s greater than 0, right? If the function fs is concave down or f the prime of s less than 0, the trapezoidal sum under approximates the error because f the prime of s less than 0, right? So look at the picture right here, it's for this guy right here. Now let's move on to question 1. Let f be the function given by fs equals 4 to the s if 4 subintervals of equal length yields. What is the value of the left Riemann sum approximation for the interval from 1 to 3 of fs ds? We need to find delta s is going to be b minus a over n, right? And right here is 4, right? Because you have 4 subintervals. So it's going to be b, which means 3, a, which means 1, right? So it's going to be 3 minus 1 divided by 4, right? So it could be 1/2, right? So you're going to draw the number line. You're going to start from 1, right? And you're going to end up at 3, right? Now we have 4 subintervals, right? So divide this one in half, and this one in half, this one in half, right? So this one is 1.5. This is 2, and this is 2.5, right? Now we're going to use the left Riemann sum, right? So the error is the sum of f of si, right, times delta s when I go from 1 to 3, right? Now left Riemann sum, we're going to start from 1, right? So s equals 1, substitute over here, you have f of 1, right? So it could be f of 1 times 1/2 plus f of 1.5 times 1/2, right? Plus f of 2 times 1/2, right? And f of 2.5 times 1/2, right? We stop right here, right? So we're going to factor 1/2 out, right? Now f of 1, substitute 1 for s over here, you have 4, right? Plus f of 1.5, substitute 1.5 for s, it could be 4 power 3/2, right? Plus 2, So it will be 4 square plus 2.5, which means 4 power 5 over 2, right? So it will be 1 over 2 times 4 plus 8 plus 16 plus 32, right? And it's going to be 30. The answer must be A. Now let's move on to question 2. The graph of the function f is shown above for s between 0 and 3 of the following which has the least value, right? Now we look at the graph right here. This one is the function f of s, and the function f of s is decreasing, right? So then the right remain sum less than the row form 1, 2, 3 of f of s, ds less than left remain sum, right? Now ls is decreasing and concave down. It tells us that the right remain sum less than the midpoint remain sum and trapezoid remain sum, right? So the answer must be C. Now let's move on to question 3. If 3 equal subdivision of the interval from -4 to 2 are used, what is the trapezoidal approximation of this interval, right? So we need to find delta as it could be b minus a over n, right? This is a, this is b, and n right here 3, right? So it could be 2 minus -4 divided by 3, right? It could be 2. So we draw the number line right here. A equals -4, b equals 2, right? You have 3 subintervals, right? So just divide this one into 3 subintervals, right? Now, delta s is 2, right? So -4 plus 2, it could be -2, and this is 0, right? Now remember, the area of the trapezoid is base 1 plus base 2 times height divided by 2, right? So in this situation, the height should be delta s, this is the height, right? And base 1 is f of -4 and f of -2 right here, right? So you have the interval from -4 to 2 of e to the -s over 2 ds equals, right? F of s is right here. So it's going to be base 1 -4, which means f of -4 plus f of -2 times the height. The height is that s right here is going to be 2, right? Divided by 2, right? Plus the second one, f of -2 plus f of 0 times 2 divided by 2 plus the last one, f of 0 plus f of 2 times the height 2 divided by 2, right? Now 2 and 2 right here cancel out, right? So you end up with f of -4 plus f of -2, f of -2 right here could be 2 f of -2, right? F of 0 is going to be 2 f of 0, right? And then plus f of 2, right? Now f of -4, the function f of s is right here, right? So it could be e to the 4 divided by 2 plus 2 times e squared divided by 2, right? Plus 2 times e to the 0 divided by 2 plus e to the -2 divided by 2, right? Now we just factor 1/2 out, right? So the answer must be E. Now let's move on to question 4. The function f is continuous on the closed interval 2 to 8 and has values that's given in the table above, using subintervals 2 to 5. 5 to 7, and 7 to 8. What is the trapezoidal approximation of the integral from 2 to 8 of f(s) ds, right? So the integral from 2 to 8 of f of s ds is approximately, now delta s right here is 3 and 2 and 1, right? The height is right here, right? So we have f of 2 plus f of 5, right? Times the height right here, 3 divided by 2, right? Plus the second one, f of 5 plus f of 7 times the height right here, 2 divided by 2. And the last one, f of 7 plus f of 8 times the height is 1 right here, so I don't need to write, right? Divided by 2. Now I'm going to factor 1/2 amps, right? So I have f of 2 right here equals 10, right? Plus f of 5 equals 30. Altogether multiplied by 3 plus f of 5 right here equals 30. f of 7 equals 40 times 2, right? Plus f of 7 equals 40. f of 8 equals 20, right? Now we're going to simplify 1/2. 40 times 3 is going to be 120. 30 plus 40 is going to be 70 times 2 is going to be 140, right? This one is 60. Now 120, 140 is going to be 260. Plus 60 is going to be 320. 320 divided by 2 is going to be 160, right? So the answer must be C. Now let's move on to question 5. Which of the following limits is equal to the integral right here, right? So we see that a equals 3, right? b equals 5, right? And then delta s equals b minus a divided by n. It's going to be 5 minus 3 divided by n. It's going to be 2 over n, right? So we look at this one right here. We need to eliminate a and c, right? Because it doesn't have 2 over n, right? We have 2 over n right here. So f of c I. In this direction is k, right? So let's replace this one with k. It's going to be a right here, a equals 3. So it's going to be a plus k times delta s, right? So it's going to be f of a equals 3 plus k times 2 over n, right? So it's going to be f of 3 plus 2k over n. But f of s equals s to the 4 right here, right? So substitute this guy for s, so it could be f of 3 plus 2k over n equals 3 plus 2k over n altogether power of 4, right? So the answer must be D. Now let's move on to question 6. The graph of the function f prime of s, the derivative of the function f, is shown above. If f of 0 equals 0, which of the following must be true? Alright, so before we're gonna solve this problem, let's review definition of increasing function and decreasing function. Alright, so if the function f of s is increasing, then if you have s1 greater than s2, then f of s1 must be greater than f of s2, right? If you have the function f of s is decreasing, then if you have s1 greater than S2, then f of S1 must be less than f of S2, right? So we look at the function f prime of S right here. The interval from 0 to 1, right? And the function f prime of S is above the axis. It tells us that f prime of S greater than 0, right? So if f prime of S greater than 0, it tells us that the function f of S is increasing, right? So then we look at the value of S right here. S1 equals 0. S2 equals 1, right? So we have 0 less than 1. Then f of 0 must be less than f of 1, right? But f of 0 right here greater than f of 1, so this one is false, right? Now, number 2, f of 2 greater than f of 1. Look at the interval from 1 to 2. So from 1 to 2, the function f prime of S still above the axis, right? So it tells us that f prime of S still greater than 0. Then the function f of S is increasing, right? So because the function f of S is increasing, you have S1 is 1, S2 is 2, right? So we have 1 less than 2, and then f of 1 must be less than f of 2, right? So this one is 2, right? Now number 3, f of 1 greater than f of 3, right? So from 1 to 3, the function has 2 portions, right? So we look at this one from 1 to 2. We have the larger positive error, right? And from 2 to 3, we have the small negative error, right? So the positive error is clearly larger than the negative error. So overall, you have f of 3 greater than f of 1, right? But this is f of 1 greater than f of 3, so this one is wrong, right? So the answer must be B. Now let's move on to question 7. If a trapezoidal sum over approximate the interval from 0 to 4 of fs ds and a right Riemann sum under approximate the interval from 0 to 4 of fs ds, which of the following could be the graph of the function fs? Now remember, if a trapezoidal sum over approximates, it tells us that the graph of the function f of s is concave up, right? Now, the right Riemann sum under approximates, it tells us that the graph of the function f of s is decreasing, right? So, the function f of s must be concave up and decreasing. The answer must be A. Now let's move on to question 8. The data for the acceleration a of t of a car from 0 to 6 seconds given in the table above. If the velocity at t equals 0 is 11 feet per second, the approximate value of the velocity at t equals 6 computed using a left-hand Riemann sum with 3 subintervals of equivalent is. Alright, so we're going to use the left-hand Riemann sum. T equals 0 to t equals 6. We start from 11 feet per second, right? So we have 11 plus, now the width right here is 2. This guy 2 and this guy 2, right? 3 subintervals. Now the left Riemann sum, you need to pick this guy right here, 5, 2, and 8, right? So you need to multiply 2 by 5, right? Plus 2 by 2 right here, plus 2 times 8. Alright, so it will be 11 plus 10 plus 4 plus 16, right? So it will be 11 plus 30, and it will be 41. The answer must be E. Now question 9. The table above gives selected values for a continuous function f if the function f is increasing over the closed interval 0 to 2. Which of the following could be the value of the interval from 0 to 2 of f ds? Now, since the function f is increasing, it tells us that the left Riemann sum is under approximated, right? And the right Riemann sum is over approximated, right? So it tells us that the left Riemann sum less than the interval from 0 to 2 of f of s ds less than the right Riemann sum, right? Now we need to calculate the error using the left Riemann sum, right? So we look at this one right here, the width 0.5. This is 0.5. This is 0.5. And this one is 0.5, right? So it's going to be length times width, right? So the left is going to be 6 right here. 6 plus 14 plus 24 plus 28. And then times the same width, right? A factor 0.5 out, right? So I'm going to simplify. This is 20 plus 24, it could be 44 plus 28, it could be 72. 72 times 0.5, it could be 36, right? Now the right Riemann sum, I do exactly the same thing, right? So it could be 0.5 outside, right? Now we're going to pick 14, 24, 28, and 34. And this guy gives us 50, right? Now 36 less than the interval from 0 to 2 of f of s ds less than 50, right? Now we look for the values that between 36 and 50, which is 41. The answer must be B. Now question 10. A tank contains 35 gallons of water at time t equals 2 minutes. Water is flowing into the tank at a rate R of t, and where R t is measured in gallons per minute and t is measured in minutes. Selected values of R t is given in the table above, using a right Riemann sum with 3 subintervals and data from the table. What is the approximation of the number of gallons of water that are in the tank at the time t equals 11, right? So question 10 is similar to question 8. Alright, so we need to use the right Riemann sum right here, right? We start from here, 35, right? So we have 35 plus, now right Riemann sum, the width right here, 5 subtract 2, it could be 3. This is 4, and this is 2, right? Now right Riemann sum, we're going to use this guy, and this guy as heights, right? So we have 5.1 times 3 plus 4.7 times 4 plus 4.4 times 2, right? 77.9, right? The answer must be D. Now let's move on to question 11. The volume of a spherical hot air balloon expands as the air inside the balloon is heated. The radius of the balloon in feet is modeled by a choice differential function of time t, where t is measured in minutes. For t between 0 and 12, the graph of r is concave down. The table above gives selected values of the graph change of time of t of the radius of the balloon over the time interval 0 to 12. The radius of the balloon is 30 feet when t equals 5. Question C. Use a right Riemann sum with the 5 subintervals indicated by the data in the table to approximate the interval from 0 to 12 of r prime of t dt. Using the correct units, explain the meaning of the interval from 0 to 12 of r prime of t dt in terms of the radius of the balloon. Alright, now right Riemann sum 5 subinterval, right? So the width right here 2, 3, 2, 4, and 1, right? So right Riemann sum you need to pick the height right here 4, 2, 1.2, 0.6, and 0.5, right? So the interval from 0 to 12 of r prime of t dt equals length times width, right? So you have 4 times 2 plus 2 times 3 plus 1.2 times 2 plus 0.6 times 4 plus 0.5 times 1, right? And it's going to be 19.3 feet. Now, we need to explain the meaning of this one in terms of the radius of the balloon. So we need to say that the interval from 0 to 12 of r prime of t dt is the change in the radius in feet from t equals 0 to t equals 12 minutes. Now question D. Is the approximation in part C greater than or less than the interval from 0 to 12 of r prime of t dt? Alright, now we go back over here. Since the graph of r is concave down, it tells us that r double prime less than 0, right? Then r prime is decreasing, right? And we use the right Riemann sum for here, right? So using right Riemann sum for the decreasing function, it tells us that the approximation is less than the interval from 0 to 12 of r prime of t dt, right? Now let's move on to question 12. Ben rides a unicycle back and forth along a straight east-west track. The track's differentiable function b models Ben's position on the track, measured in meters from the western end of the track. At time t, measured in seconds from the start of the ride. The table gives value for b of t and Ben's velocity v of t measured in meters per second at selected times t. Question B. Using correct units, interpret the meaning of interval from 0 to 60 absolute value of v of t dt in the context of the problem. Approximates the interval from 0 to 60 absolute value of v of t dt using a left Riemann sum with the subintervals indicated by the data in the table. Alright, so you know that the interval from 0 to 60 of absolute value of v of t dt actually the total distance in meters that Ben rides over the 60-second interval from t equals 0 to t equals 60. Alright, now we're going to use the left Riemann sum to approximate this one, right? So the interval from 0 to 60 absolute value of v of t dt equals the width right here 10, right? This is 30 and this is 20, right? Now the height is going to be 2, 2.3 and 2.5, right? So we have 2 times 10 plus 2.3 times 30 plus 2.5 times 20, right? So the answer is 139 meters. Now let's move on to question 13. Train A runs back and forth on an east-west section of railroad track. Train A's velocity is measured in meters per minute. Is given by a differentiable function V8 of t, where time t is measured in minutes. Selected values for V8 of t given in the table above. At time t equals 2, train A's position is 300 meters east of the origin station, and the train is moving to the east. Write an expression involving an interval that gives the position of train A in meters from the origin station. At time t equals 12, use the trapezoid sum with the 3 subintervals indicated by the table to approximate the position of the train at time t equals 12, right? Remember, we have the final position equals initial position plus the integral from initial to final of v of t dt, right? As a of 12, right? The final one right here, initial is right here, equals as a of 2 plus integral from 2 to 12 of v a of t dt, right? Now SA of 2 is 300 right here, right? Plus the integral from 2 to 12 v a of t dt, right? Now use a trapezoidal sum with 3 subintervals, right? We need to calculate this one, right? So the integral from 2 to 12 v sub a of t dt is approximately, now the width right here 2, the width right here is 3, this is 3 and this is 4, right? So base 1 is 0, base 2 is 100, the height should be the width, right? So we have 0 plus 100 times 2 divided by 2 plus 100 plus 40 times the height right here 3 divided by 2 plus 40 plus negative 120 times the height right here 3 divided by 2, and the last one negative 120 plus negative 150 times the height is 4 right here divided by 2, right? So it's approximately negative 450, right? So the position of the train at time t equals 12 is s sub a of 12 equals 300 right here. Subtract 450, right? So it will be negative 150, right? Now we're gonna set the diagram, right? This is north, this is south, this is east, and this is west, right? So at time t equals 2, we have the train A position is 300 meters east of the origin station, right? So it's right here, 300, right? Now at time t equals 12, we get negative 150. So negative 150, it tells us that it's gonna go opposite direction, right? So this is positive, this is negative right here, right? So 150 should be right here. And the negative side right here tells us that it goes opposite direction, right? So the position of train A at time t equals 12 minutes is approximately 150 meters west of origin station. Now let's move on to question 14. Hot water is dripping through a coffee maker, filling a large cup with coffee. The amount of coffee in the cup at time t from 0 to 6 is given by a differential function c, where t is measured in minutes. Select the value of c of t is measured in ounce, all given in the table above. Question C. Use a midpoint sum with 3 subintervals of equivalent indicated by the data in the table to approximate the value of interval from 0 to 6 c of t dt divided by 6. Using correct units, explain the meaning of this one in the context of the problem. Alright, so we have the interval from 0 to 6 of c of t dt divided by 6. It's going to be approximately, now we're going to use the midpoint sum, right? 3 subintervals, right? So the first interval right here, right? The second interval is right here, and the third interval right here, and the midpoint is right here, right? So we have the width right here is to be 2, 2, and 2. So length times width, length is 5.3 right here, times the width is 2 plus 11.3 13.2 times 2 plus 13.8 times 2, right? And don't forget to divide by 6 right here, right? So it's going to be 10.1 ounce. To explain the meaning of this one in the context of the problem, we need to say that the integral from 0 to 6 CFT dt divided by 6 is the average amount of coffee in the cup in ounce over the time interval from 0 to 6 minutes. Because this guy is actually the average value of the function, use the formula 1 over b minus a, the integral from a to b of f of s ds, right? Now a equals 0, b equals 6, that's why 6 subtract 0 is going to be 6. And it's good time to stop. Thank you for watching. I hope you enjoyed the video. Remember that if you failing to prepare, you're preparing to fail.
We rise like tall buildings as the chemicals they take us higher. The night's young and it's just begun as she puts her hand in mine.